equation for the quadratic. Okay, and very last problem on that page, it has a graph, and it wants you to write the equation of the graph, and it looks like this. Something like that. Y'all's looks a lot better. So we need to figure out how this graph was transformed, right? So you see how the parabola's flipped? I'm going to go ahead and write down what all happened. So it was flipped. My vertex moved, let's see, moved to the right how many? So count how far to the right did it move. And it moved right 4. And it moved up 1, 2, 3. Okay, so what I do, don't worry about stretching it from the graphs, it's a little hard to tell. But it's obvious that it was flipped. It's obvious that it was moved to the right for that vertex and up 3. So that's what I want to see in your equation. Okay, so my equation should be reflected over the x-axis, so that negative should be at the beginning. Right 4, that's going to be inside the parentheses, and then the squared outside, right? And then up 3 is going to be at the very end. So that would be my equation. Okay, so whenever you do your worksheet, keep your notes out, because we've done an example of every type of problem that you'll see. And now we're going to start with square root functions. We're going to move through them a little bit faster just because the translations are the same. If I have something inside the square root, it's going to move it left or right, and it'll do the opposite of what you think. If I have something on the outside, it'll move it up or down. Negatives are going to flip it, stuff like that. So let's go on to the back of that page and talk about square roots. Okay, on square root functions, we're going to start out with the parent function. So let's go to our table first. They already have the x values there for you, 0, 1, 4, and 9. We're going to plug those in and figure out what the y value would be. So if I have the square root of 0 on the first x value, what's the square root of 0? 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. So I want to plot these points: 0, 0, 1, 1, 4, 2, and 9, 3. And yours will probably look a lot better. But it looks something like this. It has a curve. One thing I want you to notice is that square root functions are the inverse of quadratics, and we've talked about that before. How you just switch the x and y for inverses. We talked about that at the beginning of the year. We found inverses, we found the inverse equations, stuff like that, so that should be reviewed too. But this square root function is just the parabola on its side. Now, you're not seeing the bottom part of the parabola because if you think about it, you can't take the square root of a negative. So we don't have any negative numbers here. They would be imaginary, and you can't plot imaginary numbers because they're imaginary. So you only see the top part of the parabola. So let's look at domain. Domain is all your x's. So look at your x-axis. It goes from the left to the right. So the furthest point on our left here is 0, when x is 0. So we're going to have a bracket, 0, and then it goes to the right forever and ever. So 0 to infinity. And that infinity will have a parentheses. Okay, or you could say that y is everything greater than or equal to, not y, I'm sorry, we're talking about domain. Your x is everything greater than or equal to 0? Either one, whatever you like the best. Your range is all your y values. So if you look at your y-axis, it goes from the bottom to the top. It goes up and down. So my lowest point here for my parent function would be 0, and it goes up forever and ever. So 0 to infinity. Or you could say that y is everything greater than or equal to 0. Alright, we're going to skip that paragraph in the middle. Like I said, we've already gone over all this. I think I've actually used these notes at the beginning of the year. Maybe not. But we're going to skip that paragraph. It's just talking about how quadratics and square roots are inverses of each other. But let's go ahead and go down to the bottom of that page and look at those examples. Okay, on the first example, we have y equals negative square root of x. Okay, and like I said before, your transformations work for any type of function. So if we have a negative in front of the square root of x, how is that going to transform it? Okay, just like quadratics, it's going to flip it upside down. So flip. Or you could say it's reflected over the x-axis. Either one. So whenever I draw my graph, I'm still going to start at the origin, okay, like my parent function, but it's going to flip upside down. So instead of going up forever, it's going to go down forever and ever, like that. Okay, the next one, I have a plus 5 inside of the square root. Okay, so anytime you have a number, like plus or minus the number with the x, it's going to move it along the x-axis, so left or right. And remember, it does the opposite of what you think. So this plus 5 is actually going to move it to the left 5. So we're going to take that vertex that's normally at the origin, and we're going to move it to the left 5. Okay, and you have your graph. Okay, let's go to the next page. Work on a few of those examples. Alright, so the next one we have is y equals the square root of x minus 1. Okay, so you see how that minus 1 is with the x underneath the square root? It's going to move it to the right 1. It does the opposite of what you think. So it moves it right 1. Okay, the next one's a little bit different. You can see on the next one how you have the square root of x, and that square root line at the top stops, right? And then that minus 8 is outside of the square root. Okay? If it's outside of the square root, it's going to move it up or down. So a minus 8 is actually going to move it down 8 units. So I'm going to take my vertex that's normally at the origin, and I'm going to move it down 8. And I'm moving pretty quick because it should be a review for 1, and then for 2, like, we're just repeating the same transformation. So it should start to get a little easier. Okay, the next one, my equation has the square root of x with a plus 3 at the end. Okay, the plus 3 is outside of the square root. So what's going to happen is my square root function is actually going to move up 3 units. Okay, so I'm going to take my vertex and I'm going to move it up 3. And I have my graph. Okay, very last one, just like quadratics, anytime you have a number in front of your parent function, like this one, we have 2 in front of the square root of x. Okay, it's going to stretch it. So this one is stretched by a factor of 2. Okay, so if I'm going to stretch it by a factor of 2, it's actually going to come up a little bit higher than my normal parent function. So whatever you need to write on your notes to help you remember, but it's going to be stretched by a factor of 2. It's going to come up a little higher. Okay, so if you need to write it comes up a little higher, write it comes up a little higher. Okay. Okay, on the bottom section, we're going to list out the transformations just like we did with quadratics. And the transformations are exactly the same as quadratics. So you can just copy over the same thing. But that's what we're going to do on the bottom section. Okay, so on the first one, if I have a negative in front of the square root of x, it's going to flip it upside down. Okay, or what you'll see is that it's reflected over the x-axis. So I would definitely have both of those written down because you might see it written either way. If I have a plus h inside of the square root with the x, the plus h is going to do the opposite of what you think. Okay, it's actually going to move it left. A minus h will move it right. Okay, if I have a plus k outside the square root, if it's at the very end, without being underneath the square root, it's outside of it, it's going to move it up. A minus k will move it down. And if I have a number in front of the square root, if I multiply it by a number, it's going to stretch it.